What can the Bernoulli equation be applied to? So when we were talking about this on the key concept slide, the first equation or version of the Bernoulli equation had reference to a point 1 and a point 2. And the way to think about that is like, let's say I've got some flow lines, maybe in some region of space. And for some reason, maybe the fluid is flowing, whatever, it's getting closer together up here for some reason. Maybe there's a rock that's flowing around. I don't know. But if I said, okay, here's a point 1, then here could be point 2. That would be okay. But if instead of that, if somebody said, well, can I use this as a point 1 and then put point 2 on one of the other two flow lines? That, it turns out, is not okay. Strictly speaking, the Bernoulli equation applies to 2 points on the same flow line. In some cases, there are applications of the Bernoulli equation where the connected flow line is either not obvious or it looks like the way it's being applied is to a point on one flow line compared to a point on another flow line. Usually that's okay if you can argue at some point, maybe you're in the flow, that the flow lines have equivalent characteristics there, at least as far as the Bernoulli equation is concerned. For example, if the flow lines are all at rest somewhere, or virtually at rest, very close to at rest, so in other words, the flow speed v is equal to 0, and they're at the same pressure and at the same height there as well, then you could compare a point on one flow line there that maybe to a point that was from another flow line, as long as they both wind up in that space. Those characteristics are the same. I see that very, very commonly, and that's why I'm mentioning that, because a lot of times there's this misapprehension. You can just apply the Bernoulli equation anywhere, but you have to be careful. And in some cases it works, and in other cases it doesn't work if the two flow lines just really have different characteristics everywhere. So let's check out the answer. It says a streamline of a laminar flow of incompressible fluid. Sometimes these conditions are stretched a bit, or arguments can be made how to apply to 2 points not on the same streamline. I maybe should have said a single streamline up here to be more clear in that answer, I think.